Hi, good morning. This is Kavita Kundra, and we have come up with MSCDFSM lipid metabolism. I hope you enjoyed the last section of lipid metabolism. It is not that much difficult, it is easy, and it is the daily to daily life practices what we do. And we have got lots of knowledge about why we are not losing weight if you learn about lipid, how lipids are made, and how the carbohydrates, when they are in not used condition, not used by the body, how they get converted into lipids, and why lipids or fats or fatty acids, these are very very important, and for our body normal functions. So this is interesting chapter, and we are taking next. So let's start. Oxidation of mono and poly unsaturated fatty acid. The oxidation of unsaturated fatty acid is essentially the same process as for saturated fats. It is almost same for saturation also and for unsaturated fatty acid as well. Except when a double bond is encountered. In such cases, the bond is isomerized by specific enol CoA isomerase and oxidation continues in case of linoleate, means linoleic acid. The presence of C12 unsaturation results in the formation of dienol CoA during oxidation. This substrate for an additional oxidizing enzyme NADPH requires 2,4-dienol CoA reductase. Thus, the oxidation of unsaturated fatty acids requires cis and trans enol CoA reductase in addition to the enzyme of beta oxidation. Hence, the two enzymes are also referred as additional auxiliary enzymes. Next is oxidation of unsaturated fatty acid. The oleic acid C18 has double bond between carbon 9 and carbon 10. All naturally occurring double bond are in the cis form, and usual 3 turns of beta oxidation results in the formation of 3 molecules of acetyl coenzyme, and oleic acid become a C12 fatty acid with original cis double bond. Now being taken between carbon 3 and carbon 4. It is cis enol CoA isomerase converts the cis double bond to trans and puts the double bond in the position of 2 and 3. Now the trans enol CoA is formed and it goes through 5 more turn of beta oxidation and it forms 6 acetyl CoA molecule. Linoleic acid has 18 carbon atom with double bond in the position of 9 and 10 and 12 and 13. It goes through 3 turns of beta oxidation forming 3 acetyl CoA molecules and C12 fatty acid with 2 cis double bond in 3, 4 and 6, 7 position. This acted upon by auxiliary enzyme cis and trans enol CoA isomerase and it forms trans cis dienol CoA. Now, one more turn of beta oxidation takes place. It removes one molecule of acetyl CoA and forms cis enol CoA. This acted upon by auxiliary enzyme cis trans dienol CoA. Now one turn of beta oxidation has taken place and it removes one molecule of acyl CoA and forms cis enol CoA. This is acted upon by acyl CoA dehydrogenase and an extra trans double bond is introduced in 2 to 3 position forming trans cis dienol CoA. Now a second auxiliary enzyme called trans cis dienol CoA reductase. It utilizes NADPH and reduces one double bond and forms trans enol CoA. While the configuration of double bond is suitable for beta oxidation position, 3,4 is not suitable, so that the first auxiliary enzyme cis trans enol CoA isomerase changes the position and form trans enol CoA, and then 4 more turn of beta, forming 5 more acetyl CoA molecules. Thus, with the help of these auxiliary enzymes, linoleic acid can be oxidized completely to 9 molecule of acetyl coenzyme. All unsaturated fatty acids can undergo beta oxidation. What is lipogenesis? Lipogenesis, we all know, it's as a genesis of lipo, means synthesis of fatty acids. So acetyl can react reversibly in the degradation or synthesis of lipids, fatty acids. The fatty acids are degraded to acetyl coenzyme, and also the synthesis of lipids starts with acetyl coenzyme. Main factor is acetyl coenzyme. Because of this, now fatty acid synthesis will start. When there is oversupply of carbohydrates, the extra carbohydrates get converted into triacylglycerols, fatty acids stored in the body as triacylglycerol. Also, individual with low fat diet also convert glucose to triacylglycerols that get stored. This involves the synthesis of fatty acids from acetyl coenzyme. Esterification of fatty acid in the production of triacylglycerol. This process is called lipogenesis. The lipogenesis is not only the reversal of fatty acid degradation, but also it starts with the acetyl coenzyme and does build by addition of 2 carbon units. Fatty acids synthesized in cytoplasm, and the major lipogenic tissues are in intestine, liver, adipose tissue during lactation. The mammary gland also become a major site of lipogenesis. So means mammary gland is also getting fatty and places a heavy demand on containing supply of glucose for the synthesis of fatty acids, and then it requires total good supply of glucose for the synthesis of fatty acids. The synthesis occurs in cytosol from the acetyl CoA. This is called the Novo Synthesis. When the glucose is abundant and the amount of citrate in the mitochondrial matrix exceeds the demand by citric acid cycle, the excess citrate is transported out of mitochondria into the cytosol by dry carboxylate translocase. The citrate is cleaved by citrate lyase to provide acetyl group for fatty acid synthesis. Beside acetyl coenzyme, NADPH is also required. NADPH comes from malic enzyme glucose 6 phosphate dehydrogenase and gluconate 6 phosphate dehydrogenase and NADP dehydrogenase and NADP dependent isocitrate dehydrogenase. The key regulating enzyme of lipogenesis is CoA carboxylase. It catalyzes the synthesis of malonyl coenzyme and from acetyl coenzyme and carbon dioxide in the formation of mannoline coenzyme via acetyl coenzyme carboxylase. Biotin is tightly bound to the enzyme as prosthetic group and act as a carrier for the carboxylic group that is transferred to acetyl coenzyme. The formation of mannoline coenzyme signals in the beginning of synthesis of fatty acids. FAS means fatty acid synthase. Carry the synthesis of fatty acids from acetyl coenzyme and malonyl coenzyme. There are many reactions under this. Acetyl coenzyme is added to the cysteine and SH group of all the condensing enzyme. Acetyl coenzyme CE cis SH acetyl cis CECOASH. This is a reaction that we need to know and we need to remember always. Next is second reaction is malonyl. The malonyl CoA combines with ACP SH and then these react and what they form? They form malonyl, ACP and COASH. Third reaction is the acetyl group is transferred to malonyl group with the release of carbon dioxide. So here carbon dioxide is getting released. So malonyl ACP reacts with acetyl cis Ce and gives beta ketobutyryle ACP plus in fourth carbon. Stage, in fourth reaction, the keto group is reduced to hydroxyl group. So where there is a keto group and then now replacement by hydroxyl group. So beta ketobutyryle becomes beta hydroxybutyryl. ACP is same, here also it's same, and it comes as NADPH and it gets reduced and it is NADP after the reaction. Now the fifth reaction is beta hydroxybutyryl, the product of fourth reaction. Beta hydroxybutyryl ACP is dehydrated to form trans-mono unsaturated fatty acyl group by beta hydroxyacyl dehydrogenase activity. So beta hydroxybutyryl ACP gives what? 2-butanol ACP plus H2O. Sixth reaction, the double bond is reduced by NADPH, yielding a saturated fatty acid group, 2 carbon longer than the initial one carbon. Then 2-butanol ACP plus NADPH plus H plus gives butyride ACP plus NADP plus. Then butyryl group. Then the butyryl group transferred from ACP sulfhydryl group to CE sulfhydryl, and reaction is butyryl ACP plus CE cis SH gives ACP SH butyryl cis CE. This is catalyzed by the same transverse activity as was used previously for original acetyl group. The butyryl group is now ready to condense with new malonyl group, and then fatty acyl group becomes 16 carbon long thioesterase activity, hydrolyzes forming free palmitate, and reaction would be palmitoyl ACP plus water H2O and gives what? Palmitate plus ACP plus ACP SH. Now acetyl CoA plus 7 malonyl CoA plus 14 NADPH plus 14 hydrogen. So this is the overall reaction. Gives what? Palmitic acid 8 CoASH plus 14 NADP plus 6 H2O and 7 carbon dioxide. Palmitate is then released from the enzyme and can undergo separate unsaturation to yield other fatty acid molecules. The primary fatty acid synthesis is palmitic acid. The palmitic acid can be converted to another unsaturated fatty acid. So synthesis of unsaturated fatty acid, how it happened? Palmitic acid get converted to stearic acid by elongation of carbon chain. Then saturation of stearic acid produces oleic acid. The enzymes are located in mitochondria and endoplasmic reticulum and can use fatty acid of varying chain length and degree of unsaturated as substrates. The denaturation occurs in endoplasmic reticulum membrane as well as in the mammalian cell, involves 4 broad specificity fatty acyl CoA desaturases. These enzyme introduces unsaturation at which points? C4, C5, C6 and C9. And these enzymes cannot go beyond their limits. That's the reason they cannot synthesize either linoleate or linolenate. These acids must be provided through diet, so that is why these fatty acids are called essential fatty acids. Linoleic acid is very, very important. Why it important? Because it helps in the synthesis of arachidonic acid. And arachidonate is a precursor of prostaglandin and thromboxanes. And linoleic acid is a constituent of epidermal cells. Sphingolipids function as water permeability barrier of the skin. So that is why fatty acids are very, very And very important, when we say okay, we want to get slim, we don't want to have extra fat in our body, but it is not correct and it is not healthy for you. You need to have fats for your first and foremost is to absorb fat soluble vitamins in your body, ADEK. Also, for your good skin, you need to have good fat. Means if you want to become healthy, you can have 1 teaspoon of desi ghee, the pure desi ghee, in the morning, empty stomach. That gives wonders to your skin and body and your energy. If you're feeling lethargy or less active, then it will be wonders for you, because whenever you're having ghee and all in the morning, your whole body is getting activated, your energies are back. So thank you so much. I hope you enjoyed the lesson, and we will be coming again with the next section of lipid metabolism. Till then, bye bye, take care, and also please, please, please stay safe and stay protected. Bye bye, take care.